Good evening, everybody. Yeah, my voice is audible. So let's get this started. Right. So I have actually done some programs before in this PDF. Yeah, I have done the first block. So I have completed until binary search and I need to do bubble sort. We already know the logic for bubble sort. So let's try to do that. And if we didn't understand, we will just get to the explanation part later. I'm thinking of running this session for 3 hours. I really hope I will. So I'm including the standard library. Is this keyboard working? Let's check this out. Just wait a second. Yeah. Okay, something happened. Is the stream still running? Yeah, it is. It is still running. For some reason, if I click on no, it is doing some unquestionable things. All I'm clicking here, all I'm clicking here is enter and yeah, I think in the inside it got messed up with the function keys. Yeah, it got messed up in the inside. I think I need to open that. Always these keyboards are not working. But at least is a mouse working. Yes, I just need to clean it later. So job for later. Nation restoring I wanted and wide name. Right, so I'm declaring an array. First, let's take the size from the user. Right? Let's declare an int array of that size, and let us also declare int ing. So it's a bronze keyboard. I don't know. Okay. For I equal to 0, less than size I plus plus. Right. We're taking array of I, right? And sorting the array, let's just sort it. Is equal to 0, I less than size I plus plus. J is equals to, you know what? You can actually reduce the complexity of this one. Right. Because the last element, the need not to be checked again after that. You can do that, I think. If array of right I is greater than array of sorry, I mean array of j is greater than array of j plus 1, that means the previous element is bigger than the next element. In temp is equals to array of j, array of j is equal to array of j plus 1, and array of j plus 1 is equals to temp. That should work. And after that, we will print that for I is equal to 0 and that themselves I plus plus, right, printf horizontal backslash string array of I. This should work, I think. Let's do 10. 1, 2, 5, 6, 9, any random elements. Okay, that worked. That worked. That's great. So what is the next code? Guess I need to pop out the chart as well. Maybe someone's charting something. Selection sort. So you are taking the size and you are okay. So you are thinking minimum as I, and you are then starting from the next element of I, and you are retrieving the minimum element, and you are swapping that temporary, I mean array of I with that temp. That's it. Oh, this is 2024. Okay, that's the time right now. Is yeah, this is the one. Is okay, my voice is really annoying. Um, yeah, this is the one. Is okay, my voice is really annoying. Um, yeah, this
Can
is
I
the
reply
one.
to this one? No, I can.
Is okay, my voice is really annoying. Um, all right, so we're doing a selection sort. Yeah, this is
Can I
let me
reply to this
open
one? No, I can.
for this. Oh, wait. My voice is echoing here. Okay, my voice is really annoying. Yeah. All right, let's continue with this one. So what is happening with the selection sort? Let's say you got an array of elements. Right. Wait, you cannot. You can have. So you are assuming this as a minimum element and you are starting from here and you will pick the element. If there is any minimum element existing than this one, then you will swap it out. Let's say this is the minimum element, so it stays. In the second iteration, it will do something like this, right? It will assume this as a minimum element and oh my bad, this will again stay. And now see this it will assume as a minimum element and it will check here and 4 is less than 5, so it is the minimum element here and it will swap 4 and 5, so it will become 1 3 4 5 and 31. So two nested for loops again. So let's try to implement this code. Our bro is trying to do something. uh, okay, don't we have emojis here? Yeah, this one. I mean, I don't expect any other people other than from college. So, anyways, welcome to the stream, bro. All right. So, why did I delete all of this? See, the retrieving of the array is same. Just we are we are modifying the sorting logic. Just do that. So, for sorting the array, what did I say? The outer for loop is price equal to 0, right? I less than size, I plus plus, and you are assuming the minimum into minimum is equals to array of I. And now you are continuing from then on. So from j is equal to I plus 1. Be careful, you need to start from the next index of I and j less than size, j plus plus, right? If array of j is less than minimum, you can write minimum. Yeah, that works. So in temp is equals to array of j. You are just swapping array of j with the minimum, right? Array of j is equals to min and min is equals to temp, right? Is that it? Or wait, okay. Let's see. I don't know about this one. 5, 1, 4, 2, 3, 6. Okay, something happened here. Yeah, that's what I was expecting. All right. So you found let's take this one for the example. So you will assume this as minimum and you out of this array you got this and now you are supposed to swap this one 4 5 3 2 1. So what you're doing is you are essentially swapping the minimum and array of what? So it's not j is equal to I plus 1. Is that the one? Okay. Nah, it's not the one. Let us just check the answer, what's happening. Okay, you took minimum as I and you are starting from the next index. Okay, if array of j is equals to array of oh wait. Am I not supposed to pass the positions? Selection sort, yes. Okay. And it seems like we have a small logical error here. I'm having those many times. Oh my god. Okay. No response for that comment. Right. No, bro. She got nothing to do with this. This is actually my own notes, and I'm trying to improve my logic. Right. The code is correct. I implemented it wrong. All on me. So yeah. So what did we learn? First, minimum is equals to I, not array of I. So what is essentially happening is you are initially placing the minimum index as 0 and you are checking from 1, 2, 3, 4 and it will so and we need to like after the completion of our loop we need to get an index, right? But what we are doing here is we are entirely messing up, and as soon as we found a new one, just like the bubble sort, we did this is exactly like bubble sort, and that is not how it works. Yeah, this is wait. This is a mistake. This is a conceptual misunderstanding that I have been having since a long time. So now it's clear. So this will return the fourth index, right? Fourth index. It will return in the first iteration, and we will swap the fourth and first indices. So what will it become? 1, 4, 3, 2, and 5. Right? And now this is assumed to be sorted. It obviously is. And now it will assume this as a minimum index, and it will check again. So these two elements will be swapped. So what will I get? Now that I remember, I even wrote this wrong in the exams. So now these two elements are actually sorted. So these three elements are checked. This will be assumed as minimum, and these two. Mm, yeah, and these two are not smaller, so it will just stay as it is because we are comparing like array of I. If array of I is greater than, yeah, if array of I is greater than array of J, we are doing something like that. Right? Let us try to implement that. This is just the code block that should be working. So sorting the array. Or I is equal to 0, I less than size, I plus plus, right? So this iterates through every array, and we are setting the minimum is equals to I, the minimum index technically. Now for j is equal to I plus 1 from the next index on, j less than size, j plus plus, right? J is equal to I plus 1, j less than size, j plus plus. So you are going from the next index. If, right? If array of I, what we have assumed as minimum, is greater than array of j, right? If array of I is greater than array of j, still don't know what I'm doing. Min is equals to j. Okay. And now, after finding the minimum value index, you are just bro, what? Why is this code not going forward? Okay, can't I write array of I instead of array of mins? I mean, hold on 1 minute. Okay. Array of j. Okay. That's what I thought. All right, let's walk through this code again, guys. So the problem is first we are supposed to understand what selection sort is exactly. So let's say we have an array 5, 4, 3, 2, 1. In the ith iteration, you are placing minimum is equals to I, right? So this will be the minimum index. And then from j is equal to I plus 1, j less than size, you are scanning this array. And if you, what is happening then? Let's see. J is equal to I plus 1, j less than 1, j plus plus. If array of j is less than array of minimum, that means if you found an element that is smaller than the minimum index value, you're updating the value of j. Okay, update this. This is to update minimum value. Maybe, I mean, this kind of discussion on selection sort should be done sometime or the other because I didn't have this knowledge before. So I found a fourth index. I'm not swapping it. I'm choosing this as minimum. And again, I'm choosing this as minimum, and this goes on, and I will choose this as minimum. And after I have chosen the minimum, right, I will swap them. I will swap them in the ith loop. So this is I loop. right? How do I say that? This is okay. This is the main block, and this is the first for loop. And we are inside the second for loop. We got the minimum element, and inside the first, we will exit out of this inner for loop, and then the outer for loop, we will swap them. So there will be only I swaps at maximum. So let's see. We should be able to implement this code now. So if you found an element, right? If you found an element array of if array of min index, array of min is greater than array of j, that means you found an array of j that is smaller than the minimum value. You are updating the minimum value, and after you found the minimum value, you will swap them. If this part does not get executed, just minimum will stay as I, and it will just get swapped, right? In temp is equals to what are you swapping? Array of you are swapping array of minimum with array of I. So array of I is equals to array of min, and array of min is equals to array of I. This should be working. I don't know if this didn't work. Okay. We need to define it, declare it in the min. So 5, 5, 4, 3, 2, 1. What the heck? No, like, what is wrong? Oh, God. Array of min is equals to temp, right? I messed up with the swapping logic by overlooking it. Temp is equal to array of I is equal to array of min is equal to temp, right? The problem is I was making too much. Bro, no, not again. No, no, please. To. I gotta check that out what that error actually means. Yeah, maybe I'm trying to compile when the window is active. Yeah. Please, thank God. 5, 5, 4, 3, 2, 1. Okay. So the logic is very simple. We just had some long time understanding. Okay, are you from our section, bro? Okay. What's your name, bro? I will ask. Right. Let's see the next code. Insertion sort. Let's first try to understand this one. Right. For int I is equal to 1, I less than n, I plus plus. So you are inserting actually. Okay, that means the key will stay, okay. Yes, I need to understand the selection sort logic. Comparison with sorting algorithm. So this is the current element, okay. Wait, what? So what we did before is, yeah, that makes sense. We are doing insertion sort now. What am I even thinking? Yeah, so selection sort is like you select the minimum element. Insertion sort is like you insert the element into the correct position. Okay, you assumed this is sorted. Cool. And this is compared to what happened here? Okay, compare 12 key with 12 and 12 is in the wrong order. Key is equal to 11. Shift 12 to the right to make it space for the key. Compare 12 with 12 and correct only. So compare the key with 12. Okay. Okay, guess bro is gone. Um, mm, yeah, this seems to be the lessons that I have told. So we can use whatever space we have. Let's use this. Okay, so we are doing insertion sort now, right? Insertion sort. So let us consider an array 12, 13, 10, 9, and 5. So you are assuming this thing is sorted, and the minimum elements need to be placed in the correct position. Or is that what you are doing? For int I is equal to, okay, for int I is equal to 0, I less than an I plus plus. Okay, this is until the retrieving part, leave it. For int I is equal to 1, I less than an I plus plus. Okay, you are choosing a key. You are choosing a key and oh wait. You assumed to always already sorted. So that's why you are starting from I is equal to 1, I less than an I plus plus. J is equal to I minus 1. That means if you are here, then you need to compare from here, okay? Okay. Or J is greater than 0. Right. It's going to take us some time to learn. What? I mean, this is the hard part because we are good to go with linked list tags and views. Pretty much. Yeah. Which one are we doing insertions in? Global insertions. Key equal to well, say already sorted and then solved, right? So you are using a key. Let's see. Oh my god. We assume this is already sorted and you are choosing this key. So you are comparing this key with what? You are comparing this key with okay. Not equal to 0. Ri of j is greater than key. What does it even mean? Okay, j is equal to I minus 1. Let's do this, right? This is assumed as sorted, and this will stay in its correct position. And now these two are sorted, and now this is assumed as key, and now this will be the value of j. And since this is greater, you are skipping at one position, so you will have an empty block here. 30, 10, 9, and 5. So you are going backwards, and this is also greater, so you will leave it another position. 12, 13, 10, 9, and 5. So since there is nothing to check, it will go here. 10, 12, 13, 9, and 5. So now these three are sorted, and if you look at this one, you will compare this with this, and this. You will leave up with a space here, so you will insert it here, and similarly you will insert it here. So that is how the sorted array works. So let us try to devise an algorithm for this one. Right, so I is equal to 1, I less than n, I plus plus. So why did we start from I? Alright, do we need to declare anything before? No, actually. So what are you taking is key. So you are declaring j is equal to I minus 1 and key is equals to alright array of I you are taking it as key, are you not? Yep, array of I you are taking as key. This is the key element to be checked with others, right? And you don't know how many iterations there are going to be, that's why you are going to use a while loop. So while j is greater than or equal to 0 and array of or you can say alright key is you need to find greater. Oh my god, I'm yawning. So you need to find greater values than key. So key is less than array of j. Then what you are going to do? You are going to leave space. Array of j plus 1 is equals to array of j. Okay. You are going to do j minus minus. So why are you doing this? Array. So let's say here you this one is taken as key and this one is taken as j. So j is greater than or equal to 0, j is equal to 1, yes, and key is greater than array of j. Okay, got it. Let's say you have something like 4 and 3 here and you need to put the space here, right? So array of j plus 1 is equals to array of j. What does it even do? Here, array of j plus 1, this is array of j plus 1 and this will accommodate for 13, right? And j minus minus, so this is j and this will point to j is equal to 0 here. And now this logic will get repeated again and this position will accommodate to 12. So you are left with a kind of empty space here, right? Right. And this 10 will get placed here. Exactly. So that will be done until there is greater elements. So let us try to write the code for now. You deleted everything. H. Okay, two searching techniques and three sorting techniques. Wow. So in size, enter and size. So first lesson is all about two searching and three sorting techniques. I should have learned that. So that is person day and person size. So enter elements. Int I, you need an int I and we need an j and array of the size. Literally, I'm feeling sleepy. I will take a break and wash my face. Come on, because we need to do this. So you are taking the elements, right? Scalar array of I. Okay, you just took the elements and Now you are going to perform the with sorting, insertion sorting. Let us perform this insertion sort. So you are assuming the first element to be already sorted. So you are starting from 1 for I is equal to 1, I less than size, I plus plus. So you are starting from the second index. And you have assumed a few things here. What did you assume? You have assumed int key is equals to array of array of I, absolutely. And j is equals to I minus 1. So because you are going to start from before, right? You are making space for the key element in the already sorted array. In the place, in the array in which you have assumed it is to be sorted, you are making place there. So, and you don't know how many iterations it is going to be. So, while j is greater than or equal to 0 and array of right array of j, and what are you storing here? You problems problem right array of j one. So what do you need to check? You need to check if there is any greater element, so that you need to accommodate space. So you need to check if there is any greater element than key. Yeah, that's it. Yep. If there is any greater element than key, if there is, then you are going to like switch them to one position ahead. Array of j plus 1 is equal to array of j. You are just shifting them, that's it. And then you are going to update the value of j to minus minus. And this will make space, and at the end you will just put it there. So, yep, because you need to do j plus 1. And you use a none here because both conditions need to get satisfied. Okay, j plus 1. Okay. This logic is not logical. I mean, array of j is equal to key, or array of j plus 1 is equal to key. Don't just buy half the code. That's the problem. We need to figure this thing out. So 12, 10, 9, 8, and 5. Let's say this is assumed as sorted, and this is smaller. So we are going to make space here. That means let's have an analysis here. So this is I value is equals to 1 and j value is equals to 0, and the key is equals to 10. And you are checking it with 12. So 12 is greater than 10. So you are shifting 12 to the right side. So you will have a space here, and then 12 and 10 and 9 and 8 and 5, let's say. Right. Actually, you don't have this 10, because why will you have this 10? Array of j plus 1 is equal to array of j. That's what you have written. So in this memory position, you are replacing 12 here. So this will be 12 and this will be an empty space. Let me just erase it. Okay. And you will have a space here. And what is this position? Now wait. J is equal to 0, j minus minus. After that it will do the j minus minus. So j value has eventually become minus 1. But you need to implement, like insert it in the 0th position. That's why you are doing a j plus plus here. I mean, you are inserting in the j plus 1th position. Right, we are not by hearting it. Now we have understood it. So you have gotten the key, and that's it. So let's print the sorted array. Print The sorted array is for I is equal to 0, I less than size, I plus plus. Okay. Printf percentile d max slash t, and these are making changes in the array, so they are fine. That's it, right? That's it. We're having an extra bracket here. So let's try to run this one. What? Expected expression. Okay. I did put an is equals to here. What a mistake. Let's do the reverse 10, 9, 8, 7, and 6. Okay. Thank you. Thank you. We have successfully completed the insertion sort. Okay. Uh, so let us try to revise the things once again before going to the linked list chapter. So if you there are mainly two types of sortings here. One is the selection sort where you select the minimum element, and there is another insertion sort where you insert the element in the correct position. So let's say you have an array 12, 10, 6, 9, and 5. So you are assuming this as a minimum element, minimum index actually, because you need to not the minimum element, the minimum index. And then you are going to iterate through this array j plus plus, and you are going to check for the latest new updated minimum index. So this is going to be the updated minimum, and you are just going to swap these two things, right? So the inner for loop is going to retrieve the new minimum index, and in the outer for loop you will just swap them. You will do this until the do for I iterations. And here in the insertion sort, if you consider the same array, you have assumed this to be sorted, and you are assuming this as key element, and you are assuming this as I. This will start from here and the j will start from here, and you are going to compare these two things. If this thing is greater, you are just going to leave an empty space here, right? 12, 6, 9, 5. So you need to insert 10 here. You are inserting 10 in the correct position. So you will shift them array of j plus 1 is equal to array of j. You are just shifting them, and j minus minus, and in the outer for loop you are just going to replace that array of j plus 1 which you have left as empty as the key. That's it. That's it. That is the logic that we have been struggling to understand from the last, let's say, 30 minutes. But we have understood it now. That is a great thing. So we need to we need to implement a linked list here. Let us implement a linked list. This is a very hectic task, a long and time taking one, but we gotta do that. We gotta do that. Alright, so to implement a linked list, we need to have a structure, we need to have a create function, and we need to have an insert function. Right, let us write the algorithm for this one. So we have done this like a lot of times before. You need to have a create. you need to have a display, you need to have an insert, and you need to have three things here: insert at beginning and at end and at specific position, and deletion you need to have at beginning, at end, and at specific position. Let's have a menu driven drive, right? Menu at the end, which one for right, one for insert. And again, if you click one, and then it will ask you one, two, three. And then if you click two, you will ask for delete, and it will again ask you for one, two, three. And then it will ask you for display. This is going to be a pretty big project in my opinion, but let's do this. Let's get coding and stdio.h and another standard library. You are going to need to actually allocate the memory. Did we have any new chats? Okay, we didn't have any. No worries. So directly, actually we can write that main function later. So shall we do these things like create? Let's do it in the professional way. Struct node in data struct node. You are going to have a pointer struct node next. All right, and actually you can write a function for everything. Struct node create. What are the parameters it is going to take? You need a data, right? So struct node new node is equals to struct node malloc size of struct node. This will allocate memory to this. You can actually use a type def here. Struct node new node, okay. New node of data is equals to data. New node of next is equals to, you can place it to null, right? And you can return that. And you can return that new node if that works. Struct node, wait, you just don't need to return that. You need to have a head, right? You need to have a temp. You need to have a head. Right. Why do you need this? You need this because you need them for the whole program. That's it. All right. And then first you will put head is equal to 0. So if head is equal to 0, that means the list has not been created yet. And you will put head is equals to new node. Okay, so that forms a that pointer will that pointer will point to the new node. Okay, if that is not equals to 0, then what will you do? Mhm. You actually need to store this one, right? Oh God. So you are just writing the create function. No, you can write that while loop in main. You can write that while loop like outside. I mean inside the main function. I don't think if my words are making sense or not. Hmm. So this is basically the structure of a linked list. So you have just made out to this part, right? You are placing this new node to head. And what is the next thing? You need to make a form, a link between this. So you need to do this temp of next is equals to new node and temp is equal to new node. So for that, once you created that, you will store the copy in the temp. Temp is equals to new node. Right. We will store that and if that is equal to 0, that means the list has not been created yet. Or you can just write it down here. Else temp of next is equals to new node and new node is equals to we'll update the value to temp. Temp of next, this is the previous node. So next part, this will point to the new node and temp is equal to new node. This should be working. All right. Are we returning any value to this one? So if you return the head, then what will happen? If you return the head, then in the display function, you can actually return the head, right? Yeah. Struct now. This is going to be a void function, void display, and this will get supplied with the head value. Should we have that? No, that is not necessary because that is displayed outside. Temp is equals to head, right? While temp next is not equals to null. Right. Printf %id temp of data temp is equals to temp of next. This should work as the display function and struct node inserted beginning. Insert so back and it will like add as a point to what to insert you need a value. It will take that. Let's say insert and beginning. Okay, okay. What's this? Oh, alright, so you very critical issues. No node is declared as a structure variable but not as a pointer. That's what I thought. You need to have a star here. You are allocating memory to a pointer but not to a variable. While temp of next. Okay, this will skip the last one as I expected. This is actually done for the insert at end function. Oh, I don't know. Void display. Okay. But it is not inserting at end, is it? Implementation of singular linked list. Hmm. So here's the positive insert an element at the beginning. Okay, the voice really got dumb. What are you supposed to do to insert at beginning? If assuming the list has been created already. Okay. Mm. The problem is in potato programming or in lead code, you don't build a list from the basic spot on. So this code might improve the understanding, but it is really not that important in my opinion, if you ask me. But still, we are not supposed to complain. We are supposed to know. Let it be. Hmm. I gotta check my trades. 27 is going. So still it is neutral. It has been neutral since a very long time. Insert at beginning. So this is the list. You need to insert a new node here. So you will create a new node and allocate memory for it. And you will place the value. So you will do something like temp is equals to head. And then you will do head is equals to new node. And then you will do like new node of next is equals to temp. This temp is equal to head. We'll store this in temp. And head is equal to new node. Head will point out to the newly created node. And then the new node of next. That means this next part will point out to the temp. That means this one. That is what we have intended to do. So this is the code. Okay. Struct node new node is equals to struct node malloc size of struct node. Okay. Node of data. So finish to come on. Data is equals to value. New node of what happening. It is supposed to show me, right? I don't know. Okay. And temp is equals to head. You stored it. And head is equals to new node. Head will point out to the new node. New node of next is equals to temp. And that will return the head. Everything will return head. This is correct. Just a heuristic function. So you need to give them space or what? Oh, I see. And if you didn't give space, it doesn't work. Yeah, it doesn't work, it seems. Yep. That is the logic and the reason. So these are all helper functions by the way. Okay, no comments or no. We still got like an hour and a half. Uh, we are thinking of doing that code until 11 o'clock, right? And meanwhile, I need to take a small break in between. So insert at end. I will store the temp is equals to head. And while temp is not equals to null, temp is equals to temp of next. That will just point out to the last node. And we have travel struct node new node is equals to struct node star out so struct node right new node data is equals to value. Where am I in a hurry? New node is equals to 0. You have created the node and you just need to take it place. Temp of next is equals to new node. That's it, right? Return head. Return head. Struct node. Use the same case. Insert at specific and it will take int post and int value. All right. So this is going to be a little complicated code. Let's say I don't expect anybody to watch my code for hours long. Even I won't watch my code for hours long. Let's say we have a linked list here and we need to insert in the second position. Right? The value is given like 10. The value is none of our business here. We will just create the list like we usually do. Okay. Okay, so let's say you need to insert at second position. To insert at second position, you need to traverse until the first position. So how will you traverse? You already know the number of iterations, right? Let us say this position is stored in POS. For int I is equals to 0, I less than POS, I plus plus, you put temp is equal to head and you will put temp is equal to temp of next, right? Because the number of iterations is already known. You will come here and this next part, right? Then you will put the temp of next is equals to new node. Okay, you placed it and actually you need to have this address as well because you need to make this link. So for that, before writing this line of code, what will you do is you will do is next node is equals to temp of next. You will do that since you haven't done it before, you will do it like struct node next node is equal to temp of next, and then you will do temp of next is equals to new node, and then you will do new node of next is equals to next node. That's it. Wow, now you have came to a position of building the logic by yourself thanks to ma'am. That taught me DS Manasa ma'am. Now I could be able to write almost 130 lines of code. So to insert a specific, you are taking the position and you are taking the value. Okay, for I will require an entire here. Struct new node is equal to no strong node value size of struct node new node get value new node of please yes still equals to 0. You have created a node and for I is equal to 0 rather than POS I plus plus. What will you do now? Okay, initially you need to place temp is equals to head and then you will go and do something like temp is equals to temp of next. Okay, you went and did the next. Temp is equal to temp of next. You went to the previous position. Now what? Now what? Struct node next node. Struct node next node is equals to temp of next. You have stored the address of the next node and now what you are supposed to do. Temp of next is equals to new node. And new node of next is equals to next node. That's it. And then you will return the head. You will return the updated head. That's and this one we always gets the first okay. Excellent. Okay. Two small issues. Wow. You are starting from head, okay? Oh yeah. I mean we have discussed it here, right? We just did not implement it. Second position means until first position. So that is position minus one. Absolutely. We just didn't write it, that's it. Missing the case checks. Okay. Okay. If yeah, we can do that if position is equals to one, then you can just call this position, right? Insert at peg, insert at peg value. Can I just call like this? Must also update. Okay. Returns in your head. Oh yeah. We used to write this that is equals to. I mean, this returns a value, so this should be stored somewhere. And if this is the case, this whole block should not run. That's why you are returning a value here. Nice, that works. And the AVL trace, you actually have this root is equals to insert root comma value, root is equal to insert root comma value. You have like a driver code. That is where you use this logic. I'm using it here. That's great. All right, this I will share that with ChatGPT. This reminds me of the driver code of any trace like root is equals to insert root comma one, root is equals to insert root comma two, and so on. Yeah, any other recursive tree pattern. That is great. We have written the insert in function struct node. You need to delete. Let's use the pastel case. Delete add tag. And this doesn't take any parameters in my opinion. I mean, why should it be taken? So let's say you have a node like this, you need to delete the beginning. So you will store the value of next node in temp and you will just connect head to temp. That's it. So how is the logic? So you will place temp is equal to head and next node is equals to temp of next. And you will update the head is equal to next node. And free the temp. Free the memory that's allocated to temp. That's it. And this should delete that. So you are placing temp is equals to that. And struct node next node is equals to temp of next. All right. And head is equals to next node pre-temp. This should make the return the updated head value. Works. Struct node delete at end. So to delete at end, wow. So yeah, we will just use this analogy. We will traverse until the previous node of the node that needs to be deleted. Temp of next is not equals to null. This is where the case comes in. So you will traverse until and you will just put it as null and you will just free this thing. That is it. It is really as simple as that. Alright. In time, rising 0. Okay. Yeah, you don't know the number of iterations, right? Temp is equals to and while temp of next is not equals to, you are setting them to null if you remember. Temp of next is not equals to null, temp is equal to temp of next. So you have traversed to the previous node of the last node and then you are setting up the temp. Right. You have traversed until the previous node. Struct node next node is equals to temp of next. And what are you supposed to do now? Right, pre next node. Let's put this temp of next is equals to null. Pre next node. This should be working and return the head. That's it. Yeah, if you can see, this doesn't take any arguments. And struct node, delete at position, it will take a in position that needs to be deleted. God, is there anybody here? Deleted position. We will make an analogy for this. This is our list. Let's say we need to delete the second position. We need to travel until the first position. We need to travel until the first position, and you need to link this one to this one, and you need to free this one. You have traveled, so this is temp, and temp of next is equals to current. You can do that. Actually, that is not the case. Current is equal to temp of next, because temp of next is defined and current is a container, and next node is equals to current of next. And what are you doing now is temp of next is equals to next node. In the temp of next, you are placing the next node, and you will free the value of the current, and you will return the new changed head. That's it. Uh, temp is equals to head. Why? Okay, you know the number of iterations already. So that's why you can use the for loop here in time. For I is equal to 0, I less than position minus 1, I plus plus. Temp is equals to temp of next. Okay, that is great. You have traveled until the previous position of the required position. And struct node current is equals to temp of next. And struct node next is equals to current of next. Okay, you have gotten them, and temp of next is equals to next node, and free the value in the current and return that. This should work. This works. You are on the right track, but there is a okay, okay, okay. Problem here. Temp moves all the way to the last node. The what? Okay. So the thing is, you can do this actually. I see. Deleted powers. It's okay. Okay, okay, okay. You can do this, dude. Temp is equals to none. Temp of next is equals to none. Position out of range. So calling over there and I have clicked on Control S, right? Yes, I need to save the changes. Yep, I will take a break for today. I might or might not do another session. But we have did great. If I do, I might do for the next hour. But we have done great today. We will see that tomorrow. Good night.